everyone. I'm Shweta Chandra. I'm a student at IIT Delhi. And I'm the lead for this session at second science, fundamental level to second science and technology. So let's start the class. So the last class that we have uh, the linear, we still was in the linear domain of topics, and we discussed the component with like interact. And during this discussion, I almost gave the answer of all the tutorial questions. And we remain in the fact that the polarization is in changes linearly with the electric field, and that I have discussed some units. So those are very fundamental thing, the units, but still like very fundamental and very easy, and most of you have gone through this in class 12, but still it's good to revise the thing. So now I'm going to delve into the nonlinear part of the updates. So as I say, that we consider nonlinear optics. That means basically the matter and wave interaction is not linear at all. Then we go into the nonlinear optics. That the matter's response is not linear. So, and so on, so then and like my professor has already discussed in the class that the nonlinear response mean when the second harmonic generation happened, the electric field is not at all sinusoidal now. The polarization is like the value in the negative direction somewhat truncated and sometimes in positive direction truncated. So the professor has already like discussed in the class a very elaborate manner, and also uh, this like this terms are like a kind of perturbation. So Taiwan is like the value of Taiwan is much more than Kai 2, and that is so much more than Kai 3, and so if the Taiwan is more than Kai 2, obviously the second observation. So basically etiquette. That is why he is so strong that Kai almost equal to Kai 2 E almost equal to Kai 3 is square. Then these are not negligible at all. Then we will see the second harmonic generation, harmonic generation, and so on. So on. And then the elliptic Maxwell equation of electric field would no longer be for the same calculation. We not also really so. So we will get make that down polarization from that polarization to make a relation to the or and on so forth. So everything right all these things will man that's why we did is that he has a linear term as a number. So P linear is basically P omega P omega omega P 3 omega P 4 omega and so on. Further in this lecture you will sorry further in this tutorial you will see or you have already seen that um, the even of the term in an isotropic medium, the even of the terms we don't get even order like non-linearity we don't get to see this. We will see the odd order non-linearity. Sorry. Mm. So this non-linearity can be like induced by many and very like and also we can measure them in very various way like in a frog the frequency resolved optical gating spider these are the granular these are the like name of the some distinct methods of measuring ultrafast pulse so that thing doesn't concern us in this film. So we'll get started with the non-linear thing. So we know yeah, like a like this. According to the summation theory, that there is a summation, but we assume that summation on the repeated cases. And similarly, we can write channel not I j k check. And so for Kai and that's on for Kai and real I in the tensor or Kai. So for Kai one, we get one rank two tensor, which is basically matrix. Similarly for Chi 2, we get a rank 3 tensor, and the rank 3 tensor has more than 9 elements basically. That's the like speciality. So so for 3, so basically we get 3 by 6. So there is a basically we can write E I J K as X I J K. So so this is the tensor which is half of chi I now can notation D I J K to D I N. Okay, so basically uh, because second how um, this thing is for plane and symmetrical notation. Um, so the notation for the IJK comes from basically JK is JK is 3 and this is 2 3 3 1 is 5. This is nothing how the more complicated for now. We just follow the device. So L, which is a 3 by 6. This is a 3 by 6 matrix, and we get like D1 1, D1 2, D1 3, D14, D15, D16, D16, D22, D23, D24, D114, D12, D15, D24, D33, D23, D13, D14. That's how we get that DIL matrix. So D12 is basically D122, D212, which is D26. So this is basically these indices can be freely permuted. So D122 can be written as D212, which becomes a D26. Similarly, D14 can be D123, and it can also permute. So that became D25. So when we go to this notation, DIL has only 10 independent elements. And we got this. Basically, typically, it would have been, as you can say, I have written the matrix in the first way as the independent one, but this thing are like according to matrix notation, these are basically this. This is 3, 4, 3, 5, 3, 6. Then using these symmetry elements that DIL can like this. So when we put this like claim in symmetry condition, we get this matrix. So Px to omega, like we are considering kind of two way. So that becomes this. Shalom. Remember, we like assume that D is half of chi ijk, and we consider chi ijk. So chi ijk is 2 into D ijk, and this thing is here, and we get Ex omega square, Ey omega square, Ez omega whole square, then 2Ey omega E Z omega, 2E X omega Ey omega, and 2E X omega Ez omega. So basically, when we deal with omega and omega 2, these things become omega 1 square. No, that I need to write it differently. So it is for omega plus omega is equal to for 2 omega. When we get omega 1 plus omega 2, when we get omega 3, that becomes px omega 3 py omega 3. This equation became like this, pz omega 3. That the polarization px omega 3 py omega 3 and pz omega 3 means polarization for the frequency omega 3 and x-axis of the polarization of frequency omega 3, y-axis for the polarization for the frequency omega 3, and z-axis for the polarization of frequency omega 3. That became 4 epsilon naught d11. Here we cannot use the permittivity like freely permitted thing, because this is omega 1 and omega 2. So it remained like this. All the 18 components are independent. It's called sum frequency generation. I am going to discuss this thing in detail also. I'm just giving you the idea that we have seen that in a linear, when chi1 was linear, we get chi1 1, chi1 2, chi1 3, chi2 1, chi2 2, chi2 3, and chi3 1, chi3 2, chi3 3. We get this one. So what we'll get when the chi2 is involved, chi2 means rank 3 tensor we'll get. So basically, for the simplicity, the scientist has introduced a 3 by 6 matrix. When it is a general condition, so we'll get this like we'll get two term, like the yz component has like two combination, xy uh, combination. Should we check? Like this. So see that what it became. So So PXPYZ is related to EXEYZ PZ like this for some frequency generation. It's in a second order nonlinear medium. So, and there's like in Boyd, first chapter of Boyd, the reference the professor has already mentioned in the class. In the first chapter of Boyd, at 1.5, you will get these things. No. And you can get the effective value of the effective and all those things, and there should be a spatial symmetry and all those things. You can go like details in details in that chapter. So let's dive on. So let's go on to the thing that we can also write this way also. Pi, the general notation can be written as Pi tau. If it is 1, then epsilon naught chi I j E j not for first order, it would be same. For second order, it should be something like that. So why I have written this thing not 2 omega, because omega can be 2 omega 1, 2 omega 2, can be omega 1 plus omega 2, and omega 1 minus omega 2. They can be many things. Similarly, you can write this as a epsilon naught. So when we write this, also chi is function of omega 1 and omega 2. We have seen that chi is a function of omega in the last class when there is only one, not only one, and the linear interaction is happening, and there is only linear optics we are considering. But here we know that when nonlinear optics is involved, we need to open our game, and also chi will be involved. Now chi will not only be the function of omega, they will be function of omega and omega 2. And here, if omega 1 and omega 2 is equal, then chi will be only the function of omega, but we are considering only general case. So when we are considering third order nonlinearity, so the chi will be the function of omega 1, omega 2, omega 3, omega 4, and would be j omega 1. So it's basically not omega 4. So omega 4 can be anything. So this is basically tau. The whole picture for third order Sasek non-linearity. So this is big omega and this is small omega. So here omega can be many things. 3 omega 1, 3 omega 2, 3 omega 3, omega 1 plus omega 2 plus omega 3, omega 1 plus omega 3 minus omega 3, so on and so forth. I'll discuss in the today only in the next part. So we can write chi total into E as chi linear plus chi non-linear into E. Second order, if we consider only second order, so chi total E would be written as chi linear plus, which will be chi 1 plus chi 2 into E into E. So this sign is basically E, like into. So the basically we can see that dimension of chi 1 will be equal to dimension of chi 2E. If we consider chi total into E, consider third order non-linearity, we will say that it will become, sorry, should write it from here. And write it like this. So these images, these signs I am giving, they are basically denoting multiplication here. And we know that chi 1, chi 2, chi 3 are not like scalar thing. So they will follow the tensor multiplication. If the material has a the inversion or the material is centrosymmetric, then chi even, all the chi even are zero basically. Only non-centrosymmetric materials are even not equal to zero. So now go into the matter, which is JK equal to the second order non-linearity. So this second order non-linearity can be used as second harmonic generation. Can also call some frequency generation. Or difference frequency generation. Three-word mixing. Shift up and down conversation. So, what does mean parametric means? Parametric typically means that they do not change any quantum mechanical state of the material. Basically, non-parametric means there is changes in quantum mechanical state of the material. So in a parametric up and down conversion, see, we assume that the energy and momentum is conserved. So basically, K3 will be K1 plus K2. So delta K would be, which is K3 minus K1 plus K2 would be 0. So there would be a phase matching condition. And okay, to write it. Second one generation possesses G some frequency generations of G different frequency generation. And we will see that the is coming from the meter, kilometer, this is meter, meter, 1 plus 3. This is omega 3, which is omega 2 minus omega 1 or omega 1 minus omega 2, whatever it is. Second, third wave, like 3 wave in same means 3 wave omega 1, omega 2, and omega 3 involves are involved. So we get phase matching condition. So this is the material, whichever kind, chi1, chi2. So basically omega 1 goes into, omega 2 goes into, and we get omega 3. It can be omega, omega, and 2 omega as well. So if we consider polynomial geometry, so then with vector is for, and for a general purpose, I'm saying this is not going to be possible if we don't like consider ordinary direction and extraordinary direction. still for that. So uni will go to the matter, but we'll go into that matter. But let's like with the calculation here. So k is omega c by n, omega by c into n. So basically we can see that 2n omega is 2n 2 omega. So n omega is basically n 2 omega. And we need an isotropic media to achieve this condition. So it is possible if this is n and this is omega. So if it is a extraordinary direction and this is a ordinary direction and this is omega and this is sorry, this is omega, here it is omega, and this is in o axis, so this is 2 omega. So in e omega and o 2 omega in positive crystal we can get this. So for that's why for non-linearity we need an isotropic crystal. So an isotropic crystal side like so okay, first discuss what is for an iso how. So an isotropic crystal can be uniaxial or biaxial. So in uniaxial, at least two different crystallographic direction have different end. biaxial crystal at least three different crystallographic direction as different n. So for second order, like non-linearity, we need biaxial crystal. So basically, we are producing omega. According to this, n of omega should be n of 2 omega in SHT. And how we can get this is if they are O for ordinary direction, E for extraordinary direction. So if omega and omega are going in a ordinary direction, then 2 omega needs to be in extraordinary direction, or it can opposite. Omegas are going in. First of all, when we put omega 1 and omega 2 in a material, they has to be in different source. But when we go into put 2 omega, 2 beams of omega frequency and we get 2 omega, the 2 beam of omega frequency is not like they are given by different sources. Only one laser source has been used, and inside the material the laser beam interfere with itself and give the 2 omega. This is the practical approach. Okay. It can be happen that hypothetically I am like going to explore the combination, so that should be in this combination can happen. So basically you could have written this thing as like this also. The main purpose is thing that can write this thing as well. So basically, even in practical, you do not give 2 omega beam in a material. Basically, the omega beam comes from only one source. So either it can go like, it doesn't matter which omega is in extraordinary direction and which omega is ordinary direction. It basically matters that out of this 2 omega beam, only one beam is in ordinary direction and another is extraordinary direction. And the difference is we'll get 2 omega at ordinary direction or extraordinary direction. So this kind of phase matching is called type 1 phase matching. And this type of phase matching is called type 2 phase matching. So type 1 phase matching is the same input. The input are of same kind, but output is different. And type 2 phase matching is like the two input is different kind. And also uniaxial, as you I'm sure remember from the bachelor courses, that uniaxial uniaxial crystal have two types: positive crystal, negative crystal. So if Ne is less than No, then that is negative uniaxial crystal. And if Ne is greater than No, that is positive uniaxial crystal. So could have remembered that. So the ordinary refractive index is same in every direction. So this is NO. So for in negative N Z and O. Direction of negative crystal. For positive crystal, sorry for my drawing, is not as good as it should be. So when the NE follows this path, that at one direction the reflective index is higher than another direction and it's greater than in O at this direction. At this direct at what you know and in the Excel crystal in one direction in O and in E is equal and at another direction is not equal, and if that in that direction is Ne is greater than NO, that is positive crystal, and Ne is less than NO, that is negative induction crystal. So in positive crystal, if Ne of omega, basically Ne has to be greater than NO, so the NO needs to be with greater frequency and Ne has to be in lesser frequency, then we can phase match this thing. Any that omega is in extraordinary direction and 2 omega n is in ordinary direction. So if phase matching condition is not satisfied, then we have phase mismatch. So the phase mismatch is will be k2 omega minus 2k omega, and the coherency length because of this would be 2 pi delta k. So, the second harmonic generation in a z direction will go up like this, like up to this position in z direction, we will not get any second harmonic generation. At the point we will get a second harmonic generation, then it will fall off. We will not get a second harmonic generation, then again we will get a second harmonic generation, and so on and so forth. Okay, this is how second harmonic generation is work. So, and also we know that when second harmonic generation is taking place, that means phase matching is happening. At this point, phase matching is happening. So when phase matching is happening, we will not get any omega. So be practical. If we like put two omega beams in a material, we will not only get 2 omega, some of this omega we also get. So this is the position of this. That's where the probability of getting SST is high, then probability of getting omega is very low. And that's how this thing oscillate. Sorry. So this is I omega, and this is I of 2 omega. So this shows the probability of omega and 2 omega at outputs. And why I have said it's a coherence length. So the size of the medium should be chosen according to coherence length. So basically what I'm trying to say that this direction, this is the Z direction, according to the Z direction, which frequency we are gonna get depends when there is a phase mismatch. When there is when delta K is 0 or in phase matching condition, then LC is infinity. And SHZ will build up over the time. So there will not be any exchange. You will get 2 omega. So that I2 omega will be like this, and this will be I omega, or almost like something else. For some frequency generation, K1 is omega 1 C and omega 1. K2 would be omega 2 C in function of omega 2, and K3 would be omega 3 by C function of omega n as a function of omega 3. So an omega 3 should be, as we are getting some frequency generation like this. So well, if we are going to phase match, it should be like this: K1, K2, and that should be K3. So K3 is equal to vector summation of K1, K2, which means K1 square plus K2 square plus 2K1, K2 cos theta. This is theta. So we know that electrowave equation is dielectric medium. is this and P for second order non-linearity. P is P1 plus P2, and that can be happen as chi1e plus chi2e square. So this equation became to put this thing A minus mu naught epsilon naught this delta square is equal to mu naught epsilon naught chi linear L square E by delta square plus mu naught L square P non-linear by delta square. Or you can say that it is basically mu naught epsilon naught L square P like this. So we can write it minus L square C square L square E L T square is equal to mu naught epsilon naught and 2 L square d2 T square by dt2. So for till t2 e dt2 is equal to 0, solution was basically e naught e to the power k dot minus r n cap. Now k n l to omega can be written as I2. I2 should be the function of 2 omega and omega e omega whole square. So when we multiply each square, this portion we will get I2 omega t as we have seen in the classes. So del squared p del t square would give you or t2 square by t square give you minus I2 omega whole square e to the power minus I2 omega t. So it's not necessary that we will get 2 omega in the second order generation. So in second order omega 1, which will be epsilon naught chi 2, that will be omega 1, omega 3 minus omega 2 in E omega 3 in E star omega 2. And this thing can be denoted by absorption of frequency omega 3, then emission of frequency omega 2, we will get omega 1. Omega 2 can also be written as like this. And this would be omega 3 A star omega 1. And for omega 3, that can be written as omega 3 omega 1 comma omega 2. The notation is basically which frequency is generated from which frequencies. So this thing is basically omega 3 is absorption, material emission at omega 3, then emit omega 1. So we will get absorption which is like this, hence omega 2. I should not give the direction. It should be always in the same direction, that if omega 1 is already emitted, it will only get omega 2, and if omega 2 is already emitted, it will get omega 1, and the system goes to the ground, combines to the ground state. This is the case. Now we want to solve this equation. So there is a three case, like so basically this thing can be written as mu naught del P M B by del S. Okay. So omega plus omega is with omega, which is the special phase of sound generation. So only when we consider omega 1 and omega 2, there are three possible introduction. Omega 1 plus omega 2 is equal to like 3 omega 3 minus omega 1 gives you omega 2 and omega 3 minus omega 2 gives you omega 1. So, we assume omega 3 we assume synergetic with 3 and omega 2 is associated with 3 omega 1 is associated with 1. Well, let's say that at input if we want the output we will get IJ1 that R is inequality. This is in input side, output side we will get this one. And this will so inside the media this is input and inside the media we get E3. This is not out. So as output we will get E1, E2 and E3 because of different polarization. So basically the point is we put omega and omega 2 where they give you omega 3. Now this omega 3 can interact with another omega 1 for the medium. So you will get omega 3 with omega 1 and omega 2 as well. And amplitude will also change. So E01 will become E01 dash, but it does not complicate the equation further. So we will get coupled differential equation, which is basically three omega 3 minus n squared omega 3 by c squared n squared v3 and then t squared omega 3 is equal to mu naught del squared p omega 3 del t square. This is the one equation. Number two equation would be and third equation would be like this. So to solve this equation, we need some assumption. So the assumption is all waves are traveling along z. That means k dot r is kz. Fields are constant in xy plane. So del square v become del square d2v del z square. So that thing is v naught z. And I feel the constant that v naught is a function of z only. Z e to the power I k z minus omega t. And that will give us del z del v naught z by del z into the power I k z minus omega t plus I k e naught to the power I k z minus omega t. So d2e dz2, and we can e naught z d2 dz to e to the power I k z minus omega t plus d2 dz2 ve naught z into e to the power I k z minus omega t. And 2ik d e naught z by dz e to the power I k z minus omega t. Now comes the time for third assumption. Third assumption is dE by dz is 0. So became 2ik d e naught by dz minus k squared e naught z e to the power I k z minus omega t. So this term come from this. K square is equal to omega square n square omega by c square. And del square e del t square becomes del square e naught del t square to the power I k z minus omega t, which is basically I omega del square into e. So each equation became 2ik dE naught z dz e to the power I k z minus omega t is equal to mu naught del square. Because this term and this term will cancel out. P del t square omega. It will in half because n square omega by c square del square e del t square will make it n square omega square c square e, which is basically plus k square e naught. So this term and this term will cancel. This. again. Equal to I omega e to the power I k 3. Okay, sorry, this is not I k 3 z minus omega 3 t is equal to mu naught minus I omega 3 whole square e to the power minus I omega 3 t e to the power I k1 plus k2 z p omega 3, because p2 omega 3 is basically epsilon naught power 2 e01 omega 1 e02 omega 2 e to the power I k1 z minus omega 1 t e to the power I k2 z minus omega 2 t. So now put this thing here, you will get this down. Okay. So just basically this term and this term will cancel out. So it will become dz e03 is equal to I omega 3 whole square mu naught by 2 k 3 e to the power minus I k3z. Okay, minus will not be there. I k3z plus k1z plus k2z p of omega 3. And now put the value of p of omega 3 get I omega 3 square by 2k3 c square by 2 to the power I minus I delta kz e01 omega 1 e02 omega 2. And delta k is k3 minus k2 minus k1. So basically omega 3 is omega e plus omega 1. So from in this equation, you will see how this come. So E01, E02 is basically constant, and this term only omega 1 and omega 2 is being derivated by t, and this will give us this thing. So you could have write this p omega 3, like instead of p omega 3, you could have write uh, chi into E01 and E02 at the first place. Similarly, D01 dz, we can I omega 1 square to k1 c square e to the power plus I delta kz I2 E03 omega 3 E02 omega 2 d E01 2 dz is equal to I omega 2 square to k2 c square e to the power plus I delta kz I2 E03 omega 3 and E01 star omega 1. So the fourth assumption is that we have used unmanipulated pump. So E01 omega 1 and E02 omega 2 is constant. So if we integrate with respect to Z, E03 from this equation, let's call it 1b. It would be 2b, and this would be 2c, it's a 3b. So 1b 303 omega should be I by 2 omega 3 square by 2 k3 c square E01 omega E02 omega integration 0 to L e to the power I delta k z dz. And this will give L by 2 e to the power minus I delta k L by 2 sinc I delta k L by 2. So basically E03 omega 3 given as I omega 3 square 2k 3c square pi 2 E01 omega 1 E0 to omega 2 L by 2 e to the power L is also a function of L e to the power minus I delta k L by 2 sink function I delta k L by 2. So I omega 3 would be some constant whole square I omega 1 I omega 2 L square same functions whole square. So intensity C since C square function is like this. So intensity of I omega 3 decreases with L. So that what I have already shown you here. And also there is a sinc function that will oscillate. So intensity will decrease and oscillate with that we approximately get the same result from the coherence length analysis, and intensity is decreasing and also oscillating. Here you get that. You can write 3 here also. So that is for today. I will discuss some like similarly third order process and the 3-step model in the next class. And for the quiz part, if you go through the lectures of week 11, you will get the quiz part. You will find the quiz is very easy because everything Professor Shiv Ramakrishnan and uh, Professor Vinay Pramod sir has covered in these lectures, and some questions are like A to Z, like same as what he has discussed in the class. There, even not a single digit is changed. So I hope that will not be a problem. Thank you. And for this part, it's for your understanding. The professor doesn't and will not most probably give these things in the exam. I am only doing the calculation to make you understand that how this can happen, how n omega should equal to n2 omega, and how we can derive the electric field of omega 3 from the electric field of omega 1 and omega 2, and how the electric field of omega 3 depends on omega 1 and omega 2. So electric field and omega 3 depends on how. So for that understanding, I was doing this part. So this is purely for understanding part only. Thank you.